In our first example, we're asked to solve the absolute value of x is equal to 13. If we considered a slightly different problem, say absolute value of x is equal to 4, we can see from the work that we've already sketched out that we would have two different solutions. Because here we have the absolute value of negative 4 is equal to positive 4, and the absolute value of 4 is also equal to positive 4. Again, what we're trying to answer here with the absolute value of x is how far is x away from 0? So if what we're told is that x is 4 units away from 0, we want all of those different values, all those different solutions that would be 4 units away. Jumping back to example 1, we would have two values that would be 13 units away from 0, giving us two solutions, x equals 13 and x equals negative 13. What we can do is generalize this into a process for how we'll solve these absolute value equations. We'll set up two equations, one where we take that statement inside the absolute value bars and set it equal to the number that we have on the right hand side. And then we'll set up a second equation where we take whatever expression is inside the absolute value bars and set it equal to the opposite of whatever number was originally on the right hand side of that equal sign. That way we're getting both the number in the positive and in the negative direction that are both those same number of units away. So for example 2, we'll look at setting up those two equations. What's inside our absolute value bars is the expression x plus 2. So we'll set that equal to positive 2, the number that we originally had on the right hand side. And then we'll set up a second equation, which will be x plus 2 equal to the opposite of whatever that value is. So again, we're considering that number that would be in the negative direction or in the left-hand direction. And then we solve both equations. Subtracting 2 to the other side would give us x equals 0 as one solution. And in the second case, subtracting 2 to the other side would give us negative 2 minus that 2 we subtracted over. So we would have x is equal to negative 4. We can apply that same approach for each of these absolute value problems that we're considering in these first few examples. In example 3, we have 5x is equal to 30. So we'll drop the absolute value bars and take what's inside those bars set equal to that expression on the right hand side. And then we'll take what's inside those absolute value bars and set it equal to the opposite of that value on the right hand side, and then solve, in this case by dividing both sides by 5 to get x is equal to 6 and x is equal to negative 6. In our last example, we'll approach things the same way. We'll just have a little bit more work ahead of us to solve each of these equations. So we'll write that equation set equal to 2 and set equal to negative 2, and then look at solving both. In the first step here, we'll subtract 2 from both sides to give us 6x is equal to 0, and then dividing by 6 will not give us 6. 0 divided by 6 will give us 0. In our second equation, we'll subtract 2 to the other side, which will give us 6x is equal to negative 4, and then we'll divide by 6, which will give us negative 4 over 6. And then reducing that fraction, which we want to make sure we always do in approaching our final answer, will give us negative 2/3. An important step to take then would be once you obtain your two solutions, or however many solutions you come up with, once we obtain all those solutions, we can check our work to make sure that we're on the right track by taking those values that we came up with and substituting them back into the original equation. So what I've done is just rewritten the original problem that we had in example 2, substituting in my first solution, x equals 0, into this equation, and now we can look at solving that, or evaluating that. So on the left-hand side, we would end up with the absolute value of 2 is equal to positive 2, which is true, so we know that's a valid solution. Similarly, we can substitute in negative 4, and then evaluate to get the absolute value of -2 is equal to +2, which is also true. So both of our solutions are valid, which means we have the correct answer for that problem. And that would be a good idea to take, a good step to take for any remaining problems, to just verify your work and know that you weren't off by a small arithmetic mistake or some other error in your problem solving.